To reach net zero by 2050, industries must innovate and customers must be willing to embrace clean energy technologies. In the next decade alone, we will need 300% more power than we have today. We are excited to be part of this transition.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Hello and welcome to another edition of the Insider's Guide to Energy podcast. I'm your host, Chris Sass, and with me today is Tabitha Stine. Tabitha, welcome to the podcast.
Hi, Chris. Really excited to be here today.
I'm excited to have you as a guest, and the topic is one that interests me. We're going to talk about making steel, and it's probably going to baffle our guests, but why am I talking to a steel company about greener energy? I mean, that's going to be crazy for most people.
Yeah, Nucor Corporation, we are America's largest steel producer. We're also the largest recycler in the Western Hemisphere. What that really means is we need energy to make steel. How much energy do we need? Well, in many cases, we are the largest utility customer in the states we do business. And that really comes to the scale of the magnitude of what it takes to power 26 steel mills and over 300 locations of steel making and steel fabrication facilities around North America.
Now, that is a lot of steel. I think at one time I've heard you hold like 40% of our market share in North America for steel, or some large percentage of the market share. Are all steel mills made equal, and are they all equally impactful on the environment?
Yeah, that's a great question. We've been around for 60 years making steel, fabricating products that go into construction and energy and automotive. And the thing to realize is we've been making steel what I would call the sustainable way the entire time. We melt scrap, which is the cars, the appliances, all the products we use as a consumer every day. We melt that down and we make new steel. And so there's a very circular economy for us in making steel. I grew up in the Midwest, and as you look across the skyline of Chicago and look towards, the Indiana beaches of Lake Michigan, what you see is a skyline of traditional old steel. Old steel is produced through the process of actually mining and melting iron ore and lime, and that process is very carbon intensive. And if we compare the way we make steel to the way of the traditional old school steel making that's been around for over 100 years, we use about a third of the carbon intensity of that traditional way of melting and pouring steel.
All right. So using a third of the carbon intensity, maybe we need a little bit more education on our steel making process. How can you do it so much less? I get that maybe you're recycling, so you're not having to go through the mining part and shipping the raw materials, but there's got to be more to it.
Yeah, as we look at the steel and give you some perspective, the reason the steel industry matters so much is we're using a third of the steel or of the energy and the carbon of our competitors, both, internationally and domestic. But on a global scale, 70% of all steel is made through that dirtier process that we call extractive. It's the mining process of using those materials and actually, putting them in the furnace compared to just the circularity of the carbon that we have in the steel that we're recovering every single day. And so it's important to realize that by completely converting the industry to finding ways to use electric arc furnaces, we could have a transformation, but it's not going to happen overnight. It's a big process overall.
You talked about the electric arc furnace and being a utility's largest customer. That sounds like you're using a lot of electricity. What are you doing to manage that? Because you still need the electricity. So how are you getting greener using electricity?
So it's really important that we work with our utility customers to find ways to truly pivot from carbon intensive electricity sources to clean energy sources. But the thing to appreciate is a lot of us in our homes, we're using maybe solar panels on our roof, or we see wind towers when we're driving, but we can't power a steel mill based off that as our base load. That's the challenge. And so what we're really looking at is securing renewable energy such as that, but we really have to pivot to a more standalone clean energy source. And for that, we're really leaning heavily into nuclear. And that could be new nuclear and fission or fusion or even traditional nuclear.
And I know in our pre-call we talked a bit, and you talked about making an investment, and you just said, you got fission and fusion. Fusion, they've always said, is 30 years away. So you guys are investing in fusion?
We are. We've invested $50 million total, $15 million in fission technology and $35 million in fusion. And we are very excited and committed that we feel that we have a partner that's going to be able to help us power one of those steel mills by the end of this decade. And we truly feel that's going to be transformational, not just for us, but other industrial partners, customers of ours, and the communities that we serve.
All right, so you're making a bet on the future. I'm excited to hear about that. I actually was, throwing the 30-year line out there. I think for most of the fusion folks I've talked to more recently, they think in 10 years that there'll be something to do, probably not commercialized, but they'll be where they need to be. I guess, do you also move your plants, or are you located near greener energy? You mentioned nuclear. We're not really building a lot of large nuclear plants these days for base load. So is that where your plants are going, or your facilities are put?
Yeah, as we look at, energy is a big driver where we build new facilities. It's also the states we do business, the utility partners that we've had for decades. How do we secure the energy? And it's important to realize that while we need a lot of energy, so do all the new onshoring manufacturing plants and data centers and AI technology that moves forward. And we have to realize that the steel that we sell today that's going into, say, a new AI data center, that data center customer needs steel for their servers, for their buildings. They also need the equivalent power that we need at our largest steel mills here in the US, which is unfathomable, that much power. So
for a single data center or for a region?
No, for a single data center.
You're saying a single data center is going to use as much power as a steel mill, and with the AI revolution coming?
Absolutely. And so as you think about, we go into a state, we want to build a steel mill. There's also tech companies that are showing up asking for that same power. And that's the challenge. These states are needing to double capacity while also decarbonizing, and they've put together target goals over the next decade. So we have to be very careful. Where are the states that we want to do business? Who are our partners that we're going to be able to possibly share power with? And so this is why we've decided we can't sit back and be idle. We have to have a seat at the table, and we also have to accelerate the adoption of sometimes first-of-a-kind technology, such as fusion technology, and say, we're willing to be an off-taker. We're willing to bring customers to the table who are also willing to be off-takers. And does that accelerate maybe regulation acceptance in local markets? And so remember, we're not going to just move our steel mills to where energy is, but we're willing to buy VPPAs in the meantime and really kind of consider on-site small modular reactors as maybe a technology that we bring power to our locations and to our communities.
You mentioned partnerships in that statement in the beginning, kind of opening. You kind of went over it pretty quickly. What kind of partners are you talking about to help achieve these goals?
Yeah, I mentioned the tech companies, and it seems like an odd relationship for us and a tech company to get together. But here's where the magic happens. We've been a steel producer for over 60 years. We are the largest utility customer in many jurisdictions where we operate. And we also realize that the people building across the street from us, who are these tech companies, they're new to the market. They need access to clean power, maybe some enhanced relationships with utilities. And we looked at each other and said, why don't we work together as industrial partners? And, what's in it for the states and communities is economic development. We're bringing jobs to local areas. We're bringing acceleration of clean energy to communities. And so we looked across the street and said, guess what? We're selling you steel. Why don't we pair up together and both signal to the market that says we're willing to be off-takers of this energy? And can that help accelerate the scaled adoption of all these things that are coming to light?
All right. So you've partnered up, you're doing the off-take.
Yeah.
I guess as this is evolving and the demand is going on, but you're also a public company, are you not? You not have shareholders. Your mission isn't to save the planet. Your mission is to
No,
make a return on investment, correct?
yeah, there's no question that shareholder value is very important to everything that we do. And so we're not here to make steel more expensive. We're not here to lose on any of our return on invested capital. And so how we do this with other many public companies, such as we've announced an advanced market commitment with Google and Microsoft earlier this year to accelerate the adoption of first of a kind technology energy. And so we know that we can't just pick an example, buy green hydrogen off the market today to power a furnace of ours. It doesn't make economical sense. But are there things that we can do with other industrial partners to help accelerate the adoption, regulation, and bringing that cost down? Absolutely. And so those are the things that there's near-term wins, but there's also that long-term vision of how do we do this with other partners to bring down that cost quick, because we will not make steel at a point where it's uneconomical.
Is United States steel curve really growing? I mean, you've heard in the past that we're not the manufacturing country we used to be. We've got EVs and automobiles kind of being assembled and put together everywhere. I mean, the IRA does drive a lot of things back onshore. What's the prospect for growth and demand for steel?
Well, it's been a very exciting last few years. Coming out of COVID, the investment that's been put in to the IIJA, which really comes down to how we're rebuilding our roads and bridges. We also have the IRA, which has really been funneling a lot to new solar construction that's happened, in addition to the CHIPS Act. So the onshoring of manufacturing of chips in this country to really improve the supply chain challenges that we had coming out of COVID. And there's been a renaissance for sure in manufacturing, and a lot of that is very steel intensive. What's also great is we have a very, very strong industry in the US that also relies on fighting the dumping of steel that comes into this country. That steel could come in raw form or even through EVs. And we've seen in the last few weeks really good, exciting traction on tariffs being brought back to fight the dumping of steel in this country, and also recent tariffs on Chinese electric vehicles coming into this country. And so we have nothing but confidence that as the future demand for growth happens for both manufacturing, residential construction, that the steel industry is going to continue to grow. And we're a growth company. We're going to keep investing and growing our company as well.
Now, the one thing that's nagging at me during this conversation is we started out and you were very proud of your recycling and how that was more efficient and reduced carbon. But then we went in to talk about data centers. You just talked about infrastructure, bridges and highways and things like that. Those things aren't producing a lot of recycled steel. They're going to sit there a really long time. So is there enough raw material in the recycling to drive the business, or are you still bringing in raw material?
No, we are an economy of consumers, of overconsumers, I would say. And just because that bridge is maybe going to last 100 years, it doesn't mean that all of us aren't going through a new dishwasher, a new car on a pretty good clip. And so the amount of scrap that we have that's continuing to come into the market, remember, we export a lot of scrap in this country too. So we have plenty of scrap to fuel our furnaces to continue to make new steel. And guess what? That bridge that will last 100 years when it's recycled still has the same qualities and benefit of the steel that will be made today. And what's great is the steel that's made today is going to need less steel than the bridge that was built 100 years ago because of the efficiencies brought. It's the technological advances. And so that's not even a concern that's even kind of went across our radar.
Now, this is an energy podcast. You mentioned you have partnerships with the utilities, your largest customers. What kind of work does a company like yours do in partnership with the utilities? So obviously you talked about investments or future technology, but day-to-day operationally, how are you working hand in hand with the utilities?
Our locations are all across the country, which means state by state, we have partnerships with those local utilities. And let's just pick an example. If there is a storm in Texas, or there is a high weather event where, guess what? It's going to be 110 degrees and the grid is going to be taxed. We are looked at as an industry that does not need redundant, consistent power. We can turn off our mills at times when the grid is being taxed. And so we're talking every day with our utilities in terms of, do we need to down cycle at a certain time this week to be able to provide relief to the grid and possibly run at an off-peak time. So that happens all the time. And we're also consciously always working with them, in relation to our rates and how reliable the power is coming to us. What is the rate structure that we have state by state? And if you look at a map of all the utility companies, it's not like it's a master contract across the whole U.S. and 300 locations. There are utility pockets, co-ops all over, and it requires very local connections between our general managers and controllers at each location with those utility partners.
So using so much energy, is energy one of your largest costs to producing steel? Is that one of the most expensive elements?
Yeah, I wish I could show you in a podcast what it feels like to be at a steel mill, because as they strike the arc of the furnace, you feel it in your chest, and you realize at that point when that electrode is melting that scrap, how much energy is actually consumed. And that and the scrap are the two largest things that it takes to make steel. And so this is why it matters. We're the largest recycler in the Western Hemisphere. Well, why? Because we want to help control and bring in scrap direct to our business and minimize any challenges with that supply chain. And so on the energy side, it requires us, the other big piece of our pie of having great partnerships with utilities so that we can continue to melt and steel 24/7, 365, and have that partnership of a reliable grid that can serve us.
Is there areas of the country where there's growth in the steel space where you're looking to grow, or where the utilities are looking to offload baseload and use you maybe to justify that? Is that one of the things in the conversations of where you choose to be, or is it just because traditionally there's been steel mills here and that's why we have steel mills, because they're zoned in here?
Well, there's a lot of different factors on why you locate a steel mill where it should be, from environmental practices to where's the scrap. It's pretty economical to take scrap from where it's actually coming. And there is a lot of scrap in the Midwest. And so you'll see the Midwest, the upper Midwest, even Pittsburgh area. It's because the river system, it's easy to move scrap in those areas. And if you compare the logistic transport of scrap in the Midwest compared to, say, the Pacific Northwest, it's very different. It's harder to move material. And so the logistics come into play quite a bit, but also the partnerships of those utilities. So I can't say that the energy is the number one. It really depends. It depends on who's going to be the customer of those products that we're making, because there's so many different types of steel and different end markets they go into. So we think about, all of those factors go into play.
In our previous conversations, you and I've talked, and you've talked about trying to get other steelmakers to adopt some of the practices that your company does. So I don't want to turn this into an infomercial for your company, but what are some of the things you'd like to see the industry do as a whole to be better stewards of the environment and perhaps better management and get to green energy?
Well, one of the big challenges out there is not a lot of steel producers are transparent with all of their Scope 1, Scope 2, Scope 3 emissions. And I think it's a big opportunity for us to bring accountability to the market by having all steelmakers put their numbers out on the table so that we can continue to allow customers to demand thresholds that everybody understands. And the pivot that many of the, what I would call extractive BOF steelmakers to the electric arc furnace, which is a circular process, is going to take decades, possibly, with billions of dollars of investment of things that we're already doing today. And so the first thing is let's all be transparent around the technologies and all the emissions from everything from inputs to outputs to steelmaking process, so that we can all work together towards continuing to green our grid and provide the cleanest steel on the planet.
You mentioned SMRs in the previous part of our conversation. And I've talked to many, a lot of people put a lot of investment in them. There's quite a bit of interest in them. How far are those from being commercialized and something that you could use at a steel mill today?
Yeah, we're still optimistic that within the next decade, we'll get there. We wouldn't have put $15 million into a technology that we didn't feel was just the right thing to do. It's something that we feel there will be a return on the investment. However, we also realize that there are dozens and dozens of companies that are out there trying to find the best way to make it happen, to make it scalable, that can be built in a safe, economical manner. And so we're watching them all. And I think it's an exciting time. It feels a little bit like the Wild West, but in a wonderful way, that this is a renaissance for the nuclear industry in new ways that I think people like us can accelerate the adoption in tremendous ways. And so that's why we've even said we're big, but we can't do it alone. And we need to bring our customers, our tech partners, our automotive company partners side by side and say, let's do this together.
Now, is the steel of my dad's generation the same as the steel of today, or are there chemical or changes taking place in steel to make it more efficient so you maybe don't need to use as much energy as well in the process?
Yeah, that's a great point. Let's compare, my hometown is Chicago. And if you think about what's known as Willis Tower, the old Sears Tower, at the time it was built, was the tallest building in North America. If that same building were built today, it would probably use around 40% less steel. And that's because of just the innovations in making steel today with higher strengths and just the efficiencies in making steel. Today, it takes about less than a half a man hour to make a ton of steel. Prior to 1980, it was like 10 man hours to make a ton of steel. So as you think about the labor that's required, the energy that's consumed, and also just the advances in steel making, you're going to need to make less steel to get the same strength and performance qualities out of it. And I think that's the exciting part, is we're continuing to innovate. So we'll recycle our grandfather steel to make the steel today, but we're going to need a lot less.
But what I just heard you say is, because it's a lot less, if it's 40% less, you're using theoretically much less energy to consume to create that.
And we're making steel, each ton is being made more efficient too. So it's not just 40% less energy, it's also the process in we make steel, is the efficiencies in our mills are so much further advanced than what they were even 30 years ago. Going
back to more on the energy side and the consumption of energy to make this steel, is it across the board the same then, use-wise? I mean, I know you've talked about EVs, we've talked about infrastructure projects. Is steel still used in all the same ways, or are there more or less ways that steel is being consumed today?
One of the things that somebody could ask is, will steel be replaced? What's the new modern material?
That's kind of what I was trying to get at.
Yeah. Is it glass? Is it ceramics? Is it composites? What are the things that are going to replace steel? And here's the reality, is the best project, whether it's a car, a skyscraper, a data center, that's going to be built is going to be the assembly of all the best materials together. And I'll tell you, in my 25 years, predominantly in the construction industry, there's been threats of mass timber. There's been threats of high strength concrete. And what I'll tell you is, we're always making our materials better. But in general, the growth of the steel industry is continuing to not flounder at all. In fact, it's continuing to where it's been for decades. And that's because nothing can really replace the strength and resiliency and adaptability of steel. And so we're excited to partner. So let's think about an electric vehicle. As we think about the batteries that are in these vehicles, they're very heavy. And so possibly in the past, you would see aluminum being introduced into cars. Some of their goals are going back to steel just because of the strength to support some of the loads in an EV car. But we're excited to partner with composite companies, or partner for an EV car. Or if we're building a high rise, maybe steel and mass timber together. And so I think it's important to realize is we have no concerns with demand going down. It's really just the demand of all these efficient materials coming together and continuing to improve each other.
All right. We believe there's a market in the future. I said that people are probably going to be a bit skeptical that I'm talking to a steel company. So if you're talking to an environmentalist, if someone's really worried about the environment, they're worried about energy and energy transition solely for environment, what's the message to them?
We look at all the materials, from the carbon intensity to, imagine the same building built with all the different materials that are out there. I will say that the best building built is the one not built. That's the most environmentally friendly one. So I'm a big advocate for rehabilitation. How do we renovate existing structures, particularly in high-rise communities such as Chicago and New York? As people started working from home, how do we adapt those buildings for new reuse? Adaptive reuse is so important. And so those are the things we have to do. But what I can ensure every environmentalist out there is we are the cleanest steelmaker on the planet. There is no question that there is not a better way to make steel than what we do today. And while others are playing catch up to our technology, we are continuing to march forward, and we will get to net zero by 2050 with our steelmaking process. And that's exciting. We're looking at everything from our raw materials to our logistics to our transportation, and that you can be assured that the steel that's necessary to build the roads, the bridges, and honestly, disaster resistant as climate change happens. How do we survive earthquakes? How do we survive wind and heavy rainfall events through resiliency of steel construction? We need steel for all of those things, and we can produce the most environmentally friendly products and solutions on the planet.
All right. So you're very passionate. One other area before we wrap this up that you've mentioned a couple times, emissions and scope of emissions. And public companies have responsibilities now for scope 1 and 2, potentially in the future, scope 3 emissions. How are you playing into this? I mean, you said it's an important step, but I assume that it was some of the SEC and some of the other regulations that's also helping put this front and center on your radar. Yes?
I think everything. It's not just the SEC. Our customers are demanding it. I mean, I think you would see companies pushing back more if you didn't have customers demanding it. And that's the reality, is our customers are demanding transparency. And so I would say for the last 5 to 8 years, there's been pockets, and there are definitely end markets, particularly automotive, that are really pushing for all their suppliers. And what we've realized is we're ready to lean completely in and even lean in towards scope 3. And so we're going to look at what does each automaker need? What is their challenges in front of them? And how do we provide them with all the offerings that they need to continue to get closer to zero as quick as possible across all 3 scopes? And so the SEC is just one piece of it. But, if the SEC wasn't demanding it, we need to sell steel. And our customers are demanding it. And the commercial opportunity for us to be closer with them and give them true carbon accounting is probably equal or more important to our bottom line.
All right, I'm going to ask you one hypothetical, ask for your opinion. You mentioned getting to net zero in the future. What one disruptive technology is going to be the quickest thing to accelerate us to get there? You mentioned a few of them in this conversation. What's the one you're betting on personally?
Well, one of the things that we get asked a lot about is AI. How will we leverage AI to really not just accelerate the decisions that are business decisions, but how we continue to optimize the energy grid? The way energy moves across this country is antiquated. And as we continue to modernize the grid, the moving of energy, also the storing of energy at optimal times. We do have mills right now that we have battery technology where we store energy to then, and we buy it during, off-peak times and use that power between 5 and 7 to power our steel mill in the evening. And so the more we can leverage intelligent AI technology to help further optimize how we use energy, store energy, and produce our steel, I think that could revolutionize the way we're an energy customer. And again, how we help our customers secure that clean energy as well.
Cool. I think I put you on your toes enough. I'm not going to beat you up with more questions. I think it's been a fun conversation. I've got a bit more of a feel of the steel industry's perspective, your company's perspective, and what you're doing to try to make steel greener and to use green energy. I want to thank you so much for coming on the podcast today.
Chris, thanks so much. As you can tell, we are a steel industry that is leading the charge and super passionate about this direction for us and our customers. And, in the next few years, it's going to be a continued evolution that we're excited to talk about. So thanks for having me.
For audience, we hope you've enjoyed this discussion. As always, we're never afraid to go where the topics take us. We can talk steel, we can talk whatever technology you want. But if you like this content and you want to hear more content like this, don't forget to subscribe. And really important, go on YouTube, go on LinkedIn and add comments and join the conversation. We'll see you again next time on the Insider's Guide to Energy podcast. Bye for now.